It's another video, it's another day, it's another video on lists. And recall that in the last video, I mentioned that we'll be looking at lists. And so welcome to the lists class. And for that, I'm going to create a new Python file. I'm going to call this list py. All right. So we have lists, and it's good to note that Python knows a number of compound data items, or data types rather. And these data types are used to group other values. They are used to group other values together. And it's safe to say that the most versatile of these compound data types is the list. It can be written as a list of comma-separated values or items, and between square brackets. And by square bracket, I mean this. And so when you have items that are between these square brackets and that are separated with a list of with commas, that's a list. And it's good to also note that lists might contain items of different types, but usually the items all have the same types. And what does that mean? So in Python, it's possible for us to say that, and I'm just going to write something here that doesn't really exist. I'm going to say this is unsafe. And so we can have 1, we can have A, we can have B, we can have 2. Now, as you probably have noticed, this data type is different from this data type, right? And let's take it even a little bit further by doing something like this. So this data type is different from this data type, which is different from this data type. And I don't think I need to run that. We've talked about that. If you just do print type and in parentheses you put 3.0, and if you run that, you have float. So this is a float. 1 is different, as you can see, it's an integer, and A is also different, which is a string. Of course, A is the same thing as B. Recall that we said strings can be represented using single quotes or double quotes. And if you look at this, we also have string. But the thing here is that Python allows you to create a list that consists of or contains different kinds of different types, right? But in most cases, I mean, it doesn't make sense to have different types this way. So let's look at an example. So let's say we have squares, and we say 1, 4, 9, 16, and 25. Of course, these are just squares of numbers. 1 square is 1, 2 square, and so on and so forth. If we print out these squares, what do we have? We have that same list here. 1, 4, 9, 16, 25. Now we talked about indexing for strings. It's also possible for us to index lists. So and it's the same rules apply. So if you do squares of 0, what you have, of course, I'm supposed to put that in print statement. What you have is this. You have 1, as you can see here. And if you print square, remember that we did something like this. If we print outside the range, what we have is the same kind of error, list index out of range. Just recall the other time we did this. However, if you do something like this, let's see what we have. The same rule applies, where if you're slicing, where you're printing up to doesn't really matter, because in any case you have this. It's just like saying 2 all the way to the end. And the 42 here is just like saying, of course, this is not a good thing to do. I wouldn't recommend you to do that. But I'm just saying that if you see a question, maybe you're taking a quiz or you're answering questions online or something like that, just know that what you have here, as long as it's not indexing, it doesn't really give you an error, even if it's outside the index of what you're considering. However, if it's indexing, then you have an error. So if I try to do squares of 43, I would get an error, list index out of range. And so the same thing applies to list when we talk about looking at the negative. If we do squares of -1, if you've been following through, if you've watched the video on slicing and indexing strings, you would notice that if you do squares of -1, it will give you this one, right? It's the same thing. And that's what we have here, 25. So when you're thinking of this, just think of it more like the way we had string is the same way we have this indexing and slicing working for lists as well. Now, the other thing I would like to also show you here is, so let's say, oops, I pressed something. Okay, so print squares, let's say -3 all the way through the end. Can you guess what this is going to print out? What is -3? Starting at this place, we have -1, we have -2, we have -3. And so this means that we're printing from -3 all the way to the end. And so that should give us, now because it's more than 1, we should have at least 9, 16, and 25. And so let's see if that's what we get. And as you can see, we have 9, 16, 25. So that's just, and let me just print what this gives us right here as well. All right, so this here is, these are things, I mean, we've been able to demonstrate that like strings and all the other built-in sequence types, lists can also be indexed and sliced. Now, all slice operations return a new list containing the requested elements. As you see from this example, this is a new list. And so if we print this, we had that new list. And this means that the following slice returns, which I'm going to show you now, it returns a shallow copy of the list. So if you're asking for a shallow copy of a list, you can do something like these squares. So this is more like saying print, start at 0 and print all the way to the end. So this is going to give us essentially the same thing. I'm going to comment this out just so we have one output. Okay, so I'm going to, yeah, and as you can see, we have this. And that's just a shallow copy of the original squares. Now, it's the other thing we can also look at that we talked about in strings is that lists also support operations like concatenation. And so you can do something like this in lists, where I say print squares. So I want to add squares, or let me even just use a variable here, more squares. More squares equal to squares plus and a list of other squares. So we say we have 36, we have 49, which is 7 squared, 8 squared is 64, 9 squared is 81, 10 squared is 100. And so let's say we have this. I'm going to put this here. If I print more squares, what we have now would be the list squares being added to more to other lists. And so by adding I mean concatenated. So the squares list here, which we have here, is concatenated with this other list which we're adding together. And so if we print that out, we get this as an output. So one thing we also see about the differences between lists and strings is that unlike strings, which are immutable, lists are mutable. And again, let me just write it somewhere here. Lists are mutable. And what does that mean? In simple terms, is the opposite of what string is. It's that it is possible for you to change the content of lists. So while it is not possible for you to do that with strings, it's possible for you to do that with lists. So let's move ahead. Let's say we have cubes equal to 1, 8, 27, 65, and 125. So we have these cubes. If we say that we want to do, but I mean, if you know that the cubes, something is wrong with this list, because 1 cube is 1, 2 cube is 8, 3 cube is 27. However, 4 cube is not 65. And just so we confirm that, we can do print 4 raised to power of 3, just like so. We can say print 4 raised to power 3, and that gives us 64, as you see here. So let's say that this, we want to change this value because we know that this is 64, it's not 65. What we can do in this case, and if you try this with string, it's not going to work because strings are immutable, lists are mutable. So this is index at 0, index at 1, at 2, at 3, right? So we can say that cubes at index 3 equal to 64. And so if I print out cubes now, again, I forgot that. Let me print out cubes. What I should see is this. So I'm going to print out, I'm going to say print originally cubes was. Okay, so if you look at this, originally cubes was 1, 8, 27, 65, 125. But now, let me just print this somewhere here. New cubes have become, so new cubes have become this. So that's just so you know that we can, lists are mutable, and this is just what it means. If you try this using strings, it's not going to work. Now, what I want you to do is to show me another way you can also modify this, and just type that in the comment section below. I just want to see if you've been following along. Do the same for this, but let's do the same operation for this as we did here, but don't use the same thing we did here. How would you approach that? Just take that as a challenge. Now, another thing you can do is that you can also add new items at the end of the list. And how you do that is by using the append method. And so let's talk about the append method. So what you can do here is we can say cubes.append. So we can append 216. If we append 216, I'm going to, let me comment this. I'll just comment the prints. I'll leave those assignments. And if I try to print cubes here, you can see that we now have 216 appended to it. It's also possible for us to append this way, where we say that cubes.append 7 raised to power 3. And this is more like saying we want to append the cube of 7. And if we run this, we now have two things appended, 216 and 343. And this is just this is why we say that lists are mutable. Now, assignment to slices is also possible. And what do we mean? You can assign slices. So like we said, we can assign slices. And the way that happens, the way that works is, so let's say we have letters that are A, comma B, comma C, comma D, comma E, comma F, comma G. Okay. If I try to print these letters, let me take these out of the way. If I print this, you see this. Where do I have print again? This small squares. Okay. All right. So we have this as the letters we have originally, right? And so let's say we want to replace some of the values. So we want to replace this CDE with their uppercase characters. What we can do is go this way, letters of, this is 0, this is 1, this is 2, this is 3, this is 4. And so the way we can write that is saying 2 up to, but not including 5, right? So if we print this out to begin with, we should have CDE. As you can see, we have CDE, which is a list, right? So, but what we want to do is to reassign. And so we can say that letters this equal to, this is the new list now. We have C, we have the uppercase D, and we have the uppercase E. And so if we try to print letters now, what you'll see is that the first one has A, B, and then the lowercase c, lowercase d, lowercase e, but this is uppercase C, uppercase D, uppercase E. And that's another thing that is possible. Now, it's also possible to remove them. And so if we want to remove these letters we've just added to it, we want to remove it altogether. The way we can do that is by saying letters 2 colon 5 is equal to nothing. That's just more like an empty string, empty list. So if we print letters at this point now, what we have is, as you can see, we don't have that CDE any longer. And if you have any question at any point, please do let me know in the comment section and I'll do my best to answer your questions. So this is what we can do. And of course, we talked about, in fact, we can actually clear the entire list if we want to. And if you want to clear the entire list, it's just as simple as saying, this is the entire list, right? Just assign that to an empty list. And so if we print out letters now, we have nothing there at the end of this time. So one more thing again that we see we can do with lists is that we also still have that same built-in function len, which we used for strings to find out how many characters do we have in that string we also can do the same thing here, where we say, okay, how many items or how many values do we have in this list? So if we go ahead and say that, let me just grab this. Let me just grab this. And right here, if we go ahead to say that we want to know the length of the items or the values that are inside this list of letters, the way we do that is just by saying we want to know the length of the letters. And recall that we use this function also for strings. And so there's just a lot of similarity between list and strings. One of the major differences is the fact that strings are immutable while lists are mutable. So it's also possible to nest lists. And what does that mean? What it means is that it's possible for us to create a list containing other lists. So let me show you a demonstration of that now. And if you want to do that, we can say that A equal to, and again, I'm just going to copy this. And I say N equal to 1, 2, 3, right? And I say X equal to A comma N. What this gives us is a list, a nested list. So X is a list, but it's a list of lists. As you can see, A is a list, right? N is also a list. And so this is what we refer to as nested lists. We can also nest lists. So if I try to print, I'm going to print, let me print A. At this point, I'm going to print N. And at this point, I'll print X. Let me comment this out, and this, and this, and this. All right, I think that should be all. Okay, one more left there. All right, so I run this, and this is what we have here. So we have the first list, which is ABC, and we have the other list, which is 1, 2, 3, and then X just nests these two lists together in itself. Now, you might be wondering, so how do we access? Because once you have nested lists, and this is very important and very key, and I want you to pay attention to this. If you print out the first element or the first item, which of course, remember, the difference between item and index, both of them are different. Indexes start at 0, items start at 1, right? Because this is the first item, for instance. In this particular list, for instance, this is the first item, but that first item starts at index 0. And so this item, if you're thinking of it like this is an item, this is item 1, this is item 2, this is item 3, right? But this is index 0, this is index 1, this is index 2. And so you should be mindful and cautious when you are talking about these things, or when you see questions that ask you these things. So let's say now we know that X is a nested list, right? It's a list that contains other lists. How do we access, or if we try to access the first item, which is the zeroth index, what would the result be? If we try to print this out now, what I expect to see is this entire thing. And let's see how that goes. And so that's exactly what we have, because again, remember the definition of lists. It's always separated with comma. And if you look at this list, we have a list here separated with comma, and we have another list here. And inside that list, we have this separated with comma, and then separated with comma. And so if I want to access that element B itself, the way to do that, I mean this B, the way to do that would be to pick the first item in X, which is this, because that's where B is. and then I pick the second item inside that list, and that would mean the first index and this. So in order for me to get B out of this here is what I'm going to do. So if I print this, you can see B. And so you should take note that this gives you the entire list, because this is a nested list. You can see it gives you the entire list, but in order to get this one itself, what you do is to look for the index position of that particular item. And that's all I will talk about in lists. We'll continue the section, and again, it's good to remind you that what we're looking at is we're exploring the Python documentation. And so the next thing we'll look at is the first steps toward programming. The first steps towards programming. See you in the next one, and thanks for your time. Bye.